Counting principle word problems. So number 1, a word contains 2 M's, 2 E's, 2 N's, and no other repeats. Suppose one of the N's is replaced by an M. Will this replacement result in greater or fewer permutations? So normally we would say the total letters factorial divided by, so in this case when there was 2 M's, 2 factorial, 2 E's got repeated and 2 N's got repeated. And then on this, let's try that one out. So the total letters, which we don't really know, factorial. So if one of the N's is replaced with an M, okay, so now we would have 3 M's, 2 E's, and 1 N. Okay, so in this scenario, we would be dividing by, so 2 factorial, 2 factorial, 2 factorial, that's 8. In this scenario, we would be dividing by 12. So once you divide by 12, that number is going to be smaller. So let's see the situations. In the second situation, you would divide by 0, or divide by 12, creating fewer arrangements. Number 2, there's a group of 16 boys, 12 girls. How many committees of 3 people, if there must be at least 2 girls? So we could have 2 girls or 3 girls. Those are the options. So if there are 2 girls on this committee, there would have to be 1 boy to make 3, and here there would be no boys. Okay, so 2 girls, so I need 12 choose 2, and 1 boy, so 16 choose 1. Or the other situation, so I add, because they're not happening at the same time. So if there's 3 girls, I'm going to have 12 choose 3. No boys, 16 choose 0. Okay, so this is 1056. And then in that situation, it's 220, so I'll have to add them together. Number 3, 4 different sciences are offered, 3 maths, 2 Englishes. Julie must select 1 science, 1 math, 1 English. She thinks there are 9 options. She's incorrect. Show why. She's going to have to do 4 sciences and choose 1. She's going to have 3 maths to choose 1 and 2 Englishes to choose 1, which makes 4 times 3 times 2, which is 24 options. So where did Julie go wrong? She took 4 plus 3 plus 2. So Julie added 4, 3, and 2 instead of multiplying. Okay, arrangements. We have 7 adults and 7 children in a row. If the 3 children must sit together. So 1, 2, 3, 4. There's my 10 people, and the 3 children are together. So now there are 8 groups because I'm counting the 3 children as 1 group. So I move 8 groups around, and then within the group they can also move around. So that is option B. Number 5, Bella has 2 pairs of shoes, 3 pants, 10 shirts, Carrie, da-da-da. They're making an outfit. We need a shoe, you need a pant, and a shirt. Who can make more? So Bella is 2 shoes, choose 1, 3 pants, choose 1, and 10 shirts, choose 1. So 2 times 3 times 10, so that is 60. And Carrie, 4 shoes to choose 1 from, 4 pants to choose 1, and 4 shirts to choose 1. So 4 times 4 times 4, which makes 64. Who can make more? So Carrie can make more. How many different arrangements are possible in September? So total letters divided by repeats. So 1, 2, 3, 4. 9 letters. And what do we have here? We have 1, 2, 3 E's. No S repeat. P, T. I think that's it. So we divide by them, and that is option C. How many different ways can 4 girls and 4 boys be arranged in a row if the girls and boys must alternate? So there's my people I'm trying to put. So when I put somebody here, I can put anyone. So 8. Then whoever I put here, let's pretend it was a boy. Now I have to put a girl. So now I have 4. Now going back to the boys, I only have 3 boys left. Girl, I have 3, 2, 2, 1, and 1. Okay, but don't forget that that can be anybody, so it makes that double. So if you wanted to, you could say 4 factorial for the girls, 4 factorial for the boys, and times that by 2 because you have 2 ways to start. Okay, so when you multiply that out, it's 1,152. Okay, we're in a class. You are to create a committee of 4 students with at least 1 girl. Without actually solving the problem, explain the strategy you would use to find the total ways. So you would have to separate the cases. You could go the first case with 1 girl on it and 3 boys. Second would be 2 girls, 2 boys. Third would be 3 girls, 1 boy. And the fourth would be 4 girls and no boys. And then add the cases. Okay, the other way you could do this, you could do all cases with no restrictions minus the opposite event. And the opposite of having at least 1 girl is having no girls. Number 9, there are 5 men, 4 women, seating. How many arrangements are possible? So I'm going to just go my 9 spaces here. If 2 men must sit at the beginning of the row and 2 men must sit at the end of the row, so I need to put men there. So I have 5 options, and then 4, and then 3, and then 2. and then anyone else. So I have how many people left. So I've had 9 people and I've used up 4. So I have 5 people left. Okay, so if I do 5 times 4 times 5 factorial times 3 times 2, that would be the math that I'm doing. So 14,400. Group of 9, how many ways can you select a committee of 4 members? So 9 choose 4. So that's 126 in the calculator. From a group of 9, how many ways can you select a president, vice president, secretary, and treasurer? So on that one, I'm worried about picking different arrangements. So that one is a permutation. So order matters now. Because yeah, I could pick 4 people, but I could arrange them in a bunch of different positions. So explain why they're different. The order doesn't matter, and here ordering matters. (11) How many ways can you arrange the letters in volleyball? So total divided by repeats. So letters, so I have 10 letters. L's, we got 4 of them. And I think that's it. Stated as a factorial, so I can leave my answer like that. David and Sarah are in a class of 10 boys, 8 girls, committee of 3 boys, 2 girls is to be selected. Determine the possibility if David and Sarah cannot be on the same committee. Okay, so we're going to do scenarios. Okay, so first we're going to do David on, which means Sarah is off. Second, Sarah is on, which means David is off. And then the third would be that both are off. Okay, so we have 4 situations, right? They could have both been on, both been off, David on, or Sarah on. So these are the possibilities if they are not both on. Okay, so David is on, so 1 choose 1. Now I need 3 boys, so I need 2 more boys, and now I only have 9 left to pick from, because out of the 10, David's already gone. Sarah's off, so I only have 7 girls to pick from, and I need 2. Okay, so that one, when you multiply, makes 756. Plus, so Sarah's on, so Sarah choose Sarah. I need 3 boys, so I gotta choose 3 boys. I only have 9 selections because David I can't. And I need 1 more girl because Sarah's already on, and I have 7 left to choose from. So that makes 588 in my calculator. If they're both off, so I need 3 boys, and I have 9 choices. And I need 2 girls, and I would only have 7 choices. So that makes, so the total, okay, we also could have done the opposite event. So we could have done all subtract if they are both on. That should work also the same if you had done that. Okay, there's 13, there's 9 girls, 7 boys, committee of 5. How many can be formed if William must be on the committee? Okay, so William, choose William. So now I just need a committee of 5, so it doesn't matter with boys or girls. So I just need 4 more people, and I can put this, so that was 16, so now I only have 15 options. So 1,365. How many committees of 5 can be formed if there must be 2 girls and 3 boys on the committee? Okay, so not the William thing anymore. That's question A, that's separate. So if 2 girls, I'm going to go 9, choose 2 for the girls, and 3 boys, I need a 7, choose 3. 14. A hockey arena has 5 doors. Determine the number of ways you can enter in one and exit through a different. So enter times exit. How many options do I have to go in the building? 5. How many options do I have when I come through? Now I only have 4. So there's 20 ways. 15, an employee asked 10 people waiting in line at a shop, and determine the number of different arrangements possible if 2 people, Jamie and John, refuse to stand next to each other in the line. So we're going to do the all minus opposite strategy here. So if they don't want to sit beside each other, the opposite would be if they sit beside each other or stand. Okay, so all is 10 factorial. That's just with everybody. If they sit beside each other, now I only have 9 groups, and then within their group. Number 16, 8 shirts, 3 pants, 3 hats. He adds the options together to determine there were 16 outfits, but that was an error. Describe how to determine the correct. So we would do 8, choose 1, 5, choose 1 for pants, and 3, choose 1 for hats. So 8 times 5 times 3 is 120. That's 40 times 3, oops, 120. So what was the mistake? So we added those numbers together. Instead of multiplying. That was the mistake. There are 6 different books being distributed amongst 3 people. Identify which expression is showing us what we could do. So 6 books. The first person is going to have 6 options to choose 2. So then that's gone. Second person now only has 4 options that they would have to pick. And then the third person would have 2 options and only have those 2 to pick from. So that would be answer B. There's 24 movies to download. Determine the ways that she can select 15. Okay, so that's our numbers. So are we worried about the order or not? And we're not. We're just going to be picking those songs. Okay, 4 dogs, 5 cats, 3 horses. Arranging them in order, and they have to be arranged by their animal. Okay, so the groups, we have 3 groups we could arrange. So we could go dogs, cats, dogs, horses, horses, dogs, cats, etc. Then within, we could move the dogs around, the cats around, the horses around within their own group. So this is the final answer. (20) Justify why the letters of France have a greater number of possible arrangements than Canada. So France has 1, 2, 3, 4, 5, 6 letters, and it doesn't have any repeats. So we don't have to divide it by anything. And Canada has 6 letters, and then it has 3 A's. So when you think about that as a number, then France will be bigger because you don't have to divide. Otherwise, they have the same top. So France has more arrangements because there are no repeated letters to divide by. Determine how many 4-digit numbers greater than 4,000 can be made using those digits if repetition is not allowed. So if it's greater than 4,000, it could start with a 4, a 5, or a 6. Repetition is not allowed. Okay, so we have 3 options on how that could start. So we've used a digit, so let's pretend we used a 6. Now there would be only 4 digits, and then 3, and then 2 to pick from after that. So there's 72 options. 20 boys, 11 girls, selecting a team. We need to go 7 boys, 5 girls. So 20 choose 7, and 11 choose 5. So my final answer. Okay, we're going to a movie. We got 4 people going. Determine the ways they can sit in a row of 4 chairs. If Frank and Jane must sit beside each other, so they need to be together. So now there's only 3 groups to reorder, and then within the group they can do that. So that makes 12. 7 friends going to a movie. How many ways can they sit in a row if 2 don't sit together? So we're going to do all minus opposite, and the opposite is if they sit together. Okay, so the all would be just 7 people getting arranged. If the 2 people do sit together, now I only have 6 groups, and then within they can do that. Okay, so I only have 6 groups of moving around at that point. So if I do that subtraction, there's my answer. You've forgotten the code to unlock your cell phone. You know that the code is made up of 4 digits, 0 to 9. Determine the codes if repetition is allowed. So 4, so if I think 0 to 9, that means there's 10 options. I can repeat, so again, I can have 10 options, and then 10 options, and 10 options. So there's how many arrangements are. 13 adults, 18 children getting together for a trip. Determine the ways 4 adults and 7 children can be seated. If Sandra, one of the adults, must be selected. Oh, they're being selected. So I need Sandra. So Sandra, choose Sandra. I need 4 adults. So Sandra is an adult. So now I only need 3 more adults. And now I only have 12 to pick from. Sandra is an adult, so that's out. And then children. So I need 7 children, so I can pick any of the 18. Okay, so once I multiply that out, explain why 11 factorial is not the total number of 11 letter arrangements that can be formed for celebration. So the total letters for is 11, but we have some E's. We have 2 E's. And is that it? Okay, so you have to divide by repeated letters because switching the E's in position doesn't make a different arrangement. Identify the total number of ways you can do 4 adults, 4 children in a row if the children must be seated together. Okay, so if I put the 4 children together, now I have those 6 plus 1 more, I have 7 groups. And then times the 4 within the group. So that would be letter B. Okay, there are 8 cars parked in a row. Determine the number of possible arrangements if of these 8 cars, if Mrs. Jones must always park in the 3rd spot and Mr. Rodrigo always in the last. So 1 option in the 3rd position and 1 option in the last position, and then any one else. So now I have 6 left. Okay, so basically 6 factorial times a 1 times a 1, which I don't need, so that's 720. Okay, or you could say 6, 5 here, 4. So I could have done 6, 5, 4, options 3, 2, and 1. Okay, we have 4 adventure books, 5 mystery, 1 comic. How many ways can we arrange this? If we have to keep the group of books together, so we have 3 groups. We'll be arranging that. Then within, we have 4 ways we can go with the adventure books, 4 factorial ways, 5 factorial ways with the mystery, and 1 for the comic. So if we do the all groups times the within groups, okay, that answer will come out to be that. Determine how many 3-digit odd numbers less than 300 are possible using those digits. Repetition is not allowed. So less than 300, so option 1 would be that it would start with a 1. So I put a 1 there, so there's one way to do that. So if the 1 is used, we're going to go to the end here. I have to keep it odd. So how many options would I have there? I could do a 3 or a 5 to be odd. So I'd have 2, because I have to be odd. So I could have picked a 3 or a 5. And then so if I pick one of them, let's pretend a 3. I could do 2, 4, 5, 6. So I would still have 4 options. So that's 8. In option 2, I could start with a 2. That's how I could be less than 300. So if I start with a 2, there's one way to do that. And I need to be odd, but I used a 2, so now I have a 1, 3, or 5. So I have 3 options. And then after I'm done those, I would still have 4 to pick from, so that's 12. So the total, when I add the cases together, would be 20 options. Committee of 4 people selected. We got 6 high school, 5 middle year. Determine the committees, if the committees must have at least 3 high schools. So 3 high schools or 4 high schools, because I need a committee of 4, so that's my options. So if I have 3 high schoolers, I would also need 1 middle school. So when I look at how many I have 6 high schoolers to pick 3 from, 5 to pick 1 from, so that would work out to 100. If I want 4 high schoolers, I'm going to choose 4 high schoolers. I have 6, and then I don't want any middle schoolers. You don't need that. 520, you don't need that. If you want, that's what it would have been. And so this is 115 possible.